All right. So I'm going to do this. I'm going to make sure we solve it on a different set, then I'll transfer it to the other one later.
Okay.
That way we can just get them out of here.
All right, and I'll put it down on a piece of paper here too, just in case for whatever reason. So,
All right.
use the techniques you learned so far. Solve the following equations. Remember to check your solutions. X to the fourth plus 14x squared plus 45. So we could just do long division.
Yeah, that or we could just factor it.
But we're missing a square. Where it goes 4 2. We're missing x to the third and x.
What do you mean an x to the third and an x? Just factor out.
Oh, like x, just factor out as x squared?
Yeah. X squared plus 5 in parentheses and then x squared plus 9. That's the equation then solved. So you have x squared plus 5 equals 0. And x squared plus 9 equals 0. So then you have x squared, minus 5, negative 5, square root. X equals imaginary plus or minus the square root of 5. And then the imaginary plus or minus 3.
Plus or minus 3, and then square root of 5 and negative square root of 5. And then square root of 5, right?
Yeah, plus or minus the imaginary square root of 5. And then plus or minus the imaginary number of 3. I don't know, however you'd write that. I3. That would be the first one.
Yeah.
Does that make sense?
Yeah, so I got positive 3, negative 3.
They're still imaginary numbers, though.
Oh, because of the negative?
Yeah, the negative 9.
So it's positive 3i, negative 3i.
Yep.
And then it's the square root of 5.
The imaginary I square root of 5.
And then negative I square root of 5.
Yep.
Okay, yeah, that makes sense.
Okay.
B.
Let's move on. X squared plus 2x equals 5 minus x squared.
Okay. On these ones, I'm confused on how we can find like to find the domain, like how to know where the number, like what the number is between. Like it has to be like greater than 1 or less than 7, How do we find that?
Are we trying to find the domain or are we just trying to find the zeros?
Yeah, we're just trying to find the zeros, but it makes it easier if you can.
Well, the domain in this one is all real numbers. There's no stipulations.
Well, I guess maybe it's not the domain, but you know how there's like there's like a trick to find, from like, so that you're not trying numbers from negative infinity to infinity. Like usually you can find out that the zeros are going to be between negative 2 and 3 or whatever. And you're talking about.
I think I've seen what you're talking about. I don't know how to do it.
That's fine. We'll just test a whole bunch of numbers. I think there's going to be 2 solutions in this one though.
Yeah.
And so if you try,
is there a way to move one absolute value over to the other one?
I think it would just be 5 minus x squared, absolute value minus absolute value of x squared plus 2x.
Is that what it would be?
I think so.
All right. Zero. So.
So X plus 2x squared minus x squared minus 2 plus so x will equal negative 5 halves and
You say negative 5 halves.
that's what I got. Yeah.
So let's plug negative 5 halves back into the original equation.
Absolute value.
Are you plugging that back in?
Yeah.
Okay. I'm gonna keep looking.
Negative 5 halves plus 2. 5
I know. And like totally kind of accent That's what you picked.
Yeah, negative 5 halves works.
Okay.
So do you know how I found that?
Assuming you plugged it in, so you got lucky.
No, I just took out the absolute value signs, and so I wrote two different equations. So one of them was x plus 2x equals 5 minus x squared, and then the other one was x minus 2x equals 5 plus x squared. And on that second equation, once you subtract the x squared from the right side to the left side, you're left with negative 2x equals 5. And then divide by negative 2, so x equals negative 5 halves. And then I've still got to figure out the top one.
What do you mean the top one? So you did negative 5 halves. So hold on. I'm just trying to understand it. I assume you're correct.
So let's see if I can explain it better.
I'll just plug it back in and see for myself. You know, it's negative 5 halves again. Sorry.
Yeah.
See, I didn't get that as a function.
Did you put the absolute values in there?
Yeah, I got 3.75 on the left side, and then 1.25 on the other side.
So 1.25 is what you should come out with on both sides.
So if you do negative 5 divided by 2 squared, you get 6.25. Then you just subtract 5 halves.
Wait, what?
Oh, dude, I see what I'm doing wrong. I wrote down x instead of 2x on the left side.
Okay. Yeah, I was gonna say.
Yeah. Okay, we're good. We're good. Yeah, that was gonna no.
All right. Okay. So that's for the.
I was sitting there like, I don't think that's right. It wasn't. So that was for me being an idiot. Okay.
So that's the one where we flip the signs. And so now when we take down the absolute values, we need to do the original one. And so it'll be x squared plus 2x equals 5 minus x squared. And then you add x squared to both sides. And so it'll be 2x squared plus 2x equals 5. So then it'll be 2x squared plus 2x minus 5 equals 0. And then we have to factor it out, and that's how we're going to find the other zeros.
And is that all in the absolute value, or does that not matter?
No, we took out the absolute values. That's why we put two equations. And so we're satisfying the absolute value because we put the negatives in there and then we put the positives in there.
Okay. So we should have 2x squared plus 2x minus 5, right?
Yes.
All right, well, there's no way to actually solve that, so you're going to have to do the quadratic equation.
So negative 2 plus or
minus 4 minus
4ac, so it's going to be
40
plus 40.
opposite 2 plus or minus radical 44 over 4. Changes that to negative 1/2.
Negative 1 plus or minus, but then the square root of 44 can be broken down into root 11 and root 4, and so
Yeah.
so it's going to
negative
be
1
negative,
plus or minus the square root of 11 all over 2. That's what I got.
yeah, but the thing is though is you've got to remember that so it's going to be root 4 times root 11, right?
Mm-hmm.
And then the square root of 4 is 2, and then you have to times that 2 by the negative 2.
Because, okay, so I skipped a step. So if you go back to negative 2 plus or minus square root of 44 all over 4,
Yeah.
factor out the 4 before you divide. And it'll be negative 2 plus or minus 2. Because the 4 cancels out 2 or whatever. Know what I mean?
Here, maybe I'm just doing a mental. 1 second. Maybe I'm just kind of having a mental breakdown. Let's see.
It should just be like
Negative 2 times 2 plus or minus square root 11 over 4. And then it'll be negative 4 plus or minus the square root 11 over 4. So then it'll just be negative 1 plus or minus the square root 11, right?
all over 2.
Well, but you have a negative 4 over 4, so that would make it just a negative 1.
No, because the 4 doesn't factor. You don't take the 4 out because it's radical 4.
Yeah,
So
but
it
radical
turns
of 4
into
is
2.
2.
So that's how it gets the 1/2. So you should have negative 2 plus or minus 1 to radical 11 over 2.
Yeah, but radical 4 is 2.
I know. So I'm saying radical 44 breaks down to radical 11. And
Radical 11,
4.
radical 4.
And the 4 turns into a 2. Then 2 divided by 4 is 1/2. So you don't need to keep that 1. You could keep a 1 there. It would just be negative 1 plus or minus 1 square root of 11 over 2. That make sense?
Here, let me see your paper. I'm so confused.
All right, here, I didn't write it out.
Here, I'll show you. So it's going to be negative 2 plus or minus the square root of 44 over 4, right?
Mm-hmm.
Okay. And then once you break down that 44, it's going to be negative 2 plus or minus radical 4, radical 11 over 4, right?
Yep.
And then radical 4 breaks down to 2. So it's going to be negative 2 plus or minus 2 rad 11 over 4. So then it's going to be negative 1/2. plus or minus 2 rad 11. So is it going to be negative 1 plus or minus 2 rad 11 over 2?
No. Can you see the paper? See where I put the 4?
It's a little bit blurry.
Still blurry?
Yeah. So where did you put the 4?
Okay, so we'll see if it's just lighting. I'm in a pretty dark room, so. Does that not help? Right?
It looks blank.
Yeah. Oh, it's because I have it the wrong friggin' way.
Okay, yeah. It's,
Okay.
it's a little better now.
You see kind of where I put the 4, how it, because you divide the entire thing by 4, not just the first number. You have to divide the radical 44 by 4 as well. You can't just leave the radical 44 to 2 radical 11. Still turns into radical 44, but you divided the entire thing by 2. So you still have to divide.
Oh, okay. So
Does that
then
make
it would,
sense?
so then it would be so negative 1 over 2 plus or minus rad 11.
Yeah, and you just now there is a 2, and there was a 2 in front of the 11. You just have to know it turned into 1 over 2. So you could still write in the 1 in front of it. It just doesn't change anything because it's 1 times, and when it's 1 times,
Yeah. No, yeah.
it's the number it's multiplied by.
I got you.
Okay.
I'm following you.
Okay. Number 1 is done.
So then what was the zeros then? That
Negative 5 halves, and then those 2. Negative 1 plus or minus square root of 11 over 2.
or I think there's only supposed to be 2 solutions, so I think that only one of those will work. Either the plus or the minus will only work. Because there's only supposed to be 2 solutions.
I actually technically think I don't, because we took away the absolute values, right?
That was just a solve for that. Then you have to plug it back in. So it's going to be negative 2 plus,
No, it's negative 1.
or wait, I was looking at the wrong one. Negative 1 plus root 11 over what?
2.
Over 2 plus negative 1 plus root 11 divided by 2 equals 1.31, and then math absolute value 5 minus negative 1 plus root 11 divided by 2. Yeah, so I think it's the negative one because the positive one didn't work. The plus. So I think it's the minus one.
You want to do it? Should we try and plug it in first?
Yeah.
I don't exactly know how to do these. That's why I'm not actually plugging them in, because I don't know what I'm doing.
Okay. No, that's fine.
Yeah. On the other side, I did the right side, 5 minus whatever, and I got negative 13.633.
Crap. That doesn't work.
See it. What'd you get on your side?
Which side did you do?
The right side.
5 minus x squared.
Yeah.
On my side, I got
Oh, no, I didn't.
here. Let's redo this. So,
What did you get?
absolute value. So, will you read me the zero that we think we found, the plus one? So
Did
to
you
be
get 4?
no, I haven't. I don't know if I put it in right.
Because
So what?
I forgot. I didn't divide it by 2. I just divided it by 2 and I got 4.
The right side
Yeah.
with plugging which one in?
The -1 minus the minus
-1 minus square root 11 over 2.
over 2.
Okay, 1 second. -1 minus the square root of 4. Square root of 4, 11. Square root of 11. Divided by 2.
Because they're different. Let's see. Let's change our plan. Let's go with what do they turn into? What does 1 plus radical 11 divided by 2 equal?
-1 plus the radical 11.
Yeah, let's just find out what they equal and then plug in the decimals because that's got to be way flipping easier.
Yeah, that's true. -1 minus the square root of 11.
Then we'll go like 3 decimal places and call it good. And if it's close enough, that'll be the right answer.
Okay, so it'll be so it's -1 minus the square root of 11 divided by 2.
Yeah.
-2.15.
Okay, do you want to do that one and then I'll find the other one?
Yeah, and then for the plus one, it's
Yeah. Should be like 1.158.
1.158. So I'll do the left side if you'll do the right side.
The left. What do you mean the left
So-
and right?
I'll do the x squared plus 2x if you'll do the 5 minus x squared.
Number do you want to use first?
The minus one.
Okay, the -1. 5 minus 158
That
squared.
squared.
I got like 0.343036.
So we're gonna do -1. That I'm still trying to figure this out. 1 second. Math, absolute value. That squared plus 2.
I would say that works.
What'd you get?
I got 0.343.
I got 3.358. Yeah, I'd say the -1 works. All right.
Well, then let's try the positive one, just for kicks and giggles.
Yeah, just to see what happens.
That was the 1.158, right?
Yeah.
All right, I'll do the right side again. $3.659.
I got 0.658.
What'd you get?
8.
Oh, you're breaking up. Did you? I didn't. I still can't hear you.
3.658.
I'd say that one works too.
Put them both on there, I guess. I guess it's better to have more answers than less answers.
Oh, let's go with that. Okay. Number 2.
Find real and imaginary roots of the equation. All right.
Well, 0 is 1.
0 is good. So we need to find. Is this where you change them out? Is this where you find the number of times that the sign changes, and that's how many? That's the multiplicity. Never mind. So we're gonna have 5 answers, aren't we?
Yes. This one right now we have to find the 0. Find a 0. Which number off of 8? You know. So let's try the whole numbers first. What numbers do you want to take?
I'll take the positives if you take the negatives. So I'll take 1, 2, 4, and 8. And then if you want to take negative 1.
Remember, we already factored out an x.
Okay, so then it's going to be
to the 4th, 3rd, 2nd, 1st, and then just 8. That way it just makes it easier to calibrate. Calibrate, that was a freaking nerdy term. All right, I'll do the negative.
negative 6, 14, negative 16, and 8. Yeah, if you'll take the negatives, I'll take the positives.
Yep.
Nope.
Mm.
Two works.
Okay, let's do 2, because my negatives haven't worked yet. You remember the long division thing?
Yeah, it's 1, negative 4, 6, and negative 4.
Yes, it is.
Did you write that down for the quiz?
Yeah, I got all the numbers and the answers and stuff separated. I'm just want to get this done, then I'll plug it in here and like when we get done.
Okay. Yeah, I just wanted to, because it says if you don't show.
And you said positive 2, right?
Yeah, it says if you don't show work, they won't give you credit or whatever.
I know. Freaking turds.
Let's see, 1, 4, negative 2.
1 doesn't work. All right. I'll do the negatives, I guess, again.
Oh wait, hold on.
What's up?
I think I might have done that wrong. Positive
Worked for me.
Did it? Negative 4, minus 8, 6. Okay. I guess both of them might work.
What'd you do?
Oh, no. I'm good.
None of the negatives work. Do any of the positives?
Just 2.
That's it?
Yep.
Does 2 work?
Only 2 works.
Let's plug it in again.
All of them?
No, just 2. 2.
Plug. Yeah, 2 works. I just redid it.
2, 4, 0. I know. Then we'll get x squared minus 2x plus 2, and then we can get There's no way to algebraically solve that, so we're not trying to
Yeah.
whatever square roots.
So two is a factor, and then once you do the long division, your remainder is 1, -4, 6, and -4. How do we find the other zeros from here on out?
So all the algebraic, that makes sense. So what I would do, or whatever, is after you get to the x. Honestly, wasn't really paying attention to what you were saying earlier. My bad. But after you get to the x cubed minus 4x squared plus 6x minus 4. Since the only thing that works is 2, I would plug 2 back in to get x squared minus 2x plus 2, and then solve that with the quadratic equation. And then I think those would be our zeros.
Yeah, so 2 works on both of those.
Yeah.
But you can't have two. You can't have the same answer twice, can you?
No, I mean you can. You just don't write it down.
Okay, so was that just confirming that 2 was our number?
I mean, it's just, yes, but it's also a separate equation.
So far we've only found 1 0, right?
We found 2, 0 and 2.
Oh yeah, 0 and 2. So we need to
And if
find
you-
3 more.
Yeah. No, I don't think so.
Because don't you have to find the number of zeros of how big the root is?
2, guess what? 1. So on one of the homeworks, I remember that there's like an x to the 4th or negative 5th scenario had like 2 zeros there because zeros kept working again on different equations. So I don't know if it's an always you have to have thing. And if it, because I have 0, 2, then 1 plus or minus I.
So you think there's just 2 answers on this one then?
I think there's 4. I don't think there's 5.
Oh, and so now that we found the 2 real ones, I bet you there's 2 imaginary ones.
Yeah, it's 1 plus or minus I. If you take, after you replug 2 in, after you did it the first or the second time, after you plug that in, there's 2x plus 2. And then if you plug that into the quadratic formula, whatever, the opposite b plus or minus the square root of 4, or b squared.
Yeah. Comes out 1 plus or minus I.
Yeah, it comes out as 1 plus or minus I. So then you have 0, 2, 1.
So how did you get the I?
4 minus 8 is negative 4. Or, sorry. Yeah, 4 minus 8 is 4, or negative 4 in a sense. But negative 4 turns out to be 2i, but then you're dividing it by 2, so it just is 1.
Okay. Here, 1 second. Hello?
All right.
Hello? Hello? Hola. Hola. Dang it. All right. So the answers are going to be 0, 2, 1 minus I, and 1 plus I.
So I got the 1 plus or minus I.
So it was the square root of -4 over 4. Is that what you came out with when you did the quadratic equation?
Over 2, not
Oh,
4.
2.
But yeah.
And so then
So then the -4 turns into 2.
yeah, so
because
then
the
it's going to be
2 over
2i over 2
which is just I.
I. And then
Yeah.
you had the 1 plus or minus out in front.
Yeah,
Yeah.
because it was 2 plus or minus, then you divide that by 2 as well.
Okay, yeah, that makes sense. So we're going to number 3 then?
Right here. Yes, sir.
Okay. Cost of making plates of food to sell at a
For
farmer's
John.
market for John is given in
John.
dollars is 0.5x plus the square root of 8x plus 5,000. Find the
Okay.
number of plates of food for which the cost is $83.50. So we just have to put 83 in for C.
83.50, but yeah.
5x plus the square root of x plus 5,000. Square 83. So 83 squared is 6889.
0.05 squared is 0.0025.
0025x plus 8.
Plus 8x. So I guess you could just say 8.0025 plus 5,000. And what did you say 83.5 squared was?
I didn't put the 0.5 in there.
Oh,
Just
never mind.
squared.
69.
6972.25 minus 5,000 is 1972 equals 0.0025x.
8.0025x.
Hola.
And divide that by 8.0025.
I'm in the bottom of the hub. Just sitting like at a table like down there where everybody eats in the very, very bottom of the hub. Like that. Yeah. So
we would have to sell 246.45.
So then it would be 1972 divided by 8.0025.
Yeah.
So
you should get
246.
Yeah. Point something something.
Yeah, or 246.
All right. If the food sells for $4.49 per plate, what is the minimum number of plates?
Here, 1 second.
Okay.
Okay. What time do you guys leave?
Like 9:30.
All right. Be careful. You guys get tired. Call me.
I'm not even
Call me. All right. See ya. Sorry, me and my buddies are going to Mexico this weekend, and I'm flying and they're driving, and I don't want to have to check a bag, so I had to give them my liquids because you can't take liquids out of a plane. So.
Yeah. Gotcha.
So if the food sells for $4.49 a plate, what is the minimum number of plates that John must make and sell to make a profit? So then you just plug $4.49 into X.
Yeah.
So then it'll be 0.5 times 4.49 plus the square root of 8 times 4.49 plus 5,000. And so 8 times 4.49 is 3592 plus 5,000. The square root of that
Be 73.21.
I got 70.96. Did you take 8 times 449?
Yeah.
What'd you get?
I guess I got 35.92.
Okay, and then 35.92 plus 5,000 is 5,035.92.
Yeah, and then you get 70.96. And you have to add 0.05 times.
Oh, you already did the other step. 0.5.
Oh, yeah. No, I just did it one equation.
Oh,
And you should
okay.
get like
Yeah.
73.01 or something.
73.209, so 73.21.
And I'll put in the exact numbers, and then it'll be like, so technically 74, because you can't sell 0.21 of a plate.
Yeah,
But
so
I think
70,
I think that's it, man.
74 plates then.
Yep. And then I'm gonna write it out here right now, and then I'll take a picture and send it in and do that.
Okay. So on that first one,
Right.
that it'll be 2. Is that one gonna have to be 246 or 247?
That would technically be 247. I'm gonna write the decimal, and then I'm gonna be like, so she has to sell that many plates.
Okay, perfect. And then on the bottom it just says, don't forget to submit the group participation points. So
Okay.
when you submit the PDF, just let her know that we were the only ones here. And I guess that'll be that. So
Yes, sir. All right, you have fun in Mexico, man.
yeah, thanks. We'll let's do that meeting again on Tuesday at 12.
Okay, sounds good, man.
Sweet. We'll see ya.
See ya. Bye.
Bye.